Ryan Lopopolo gave his team a deadline, 5 months. Build a real product. One rule, 0 lines of human-written code. They shipped it, 1 million lines, 1,500 pull requests, 0 typed by a human. This is the OpenAI team that named the discipline you've never heard of, harness engineering. And by the end of 2026, every developer worth hiring will know it. Here's the thing nobody tells you. Your AI agent isn't broken because the model is dumb. Andrej Karpathy, the guy who literally coined the phrase vibe coding last year, just said vibe coding is dead. His exact words, quote, harnesses matter more than models. Most developers never hear that word, harness. They think upgrading from Sonnet to Opus fixes the problem. It doesn't, because the model is just the brain. The harness is everything else, the eyes, the hands, the memory, the workshop. Without a harness, the smartest model on Earth can only chat. With a great harness, even a mid-sized model ships production code. Stick with me. By minute 4, you'll see the exact architecture Anthropic uses to run autonomous coding for 6 hours straight. By minute 8, you'll know how to build it yourself. Let me make this concrete. Martin Fowler, yes, that Martin Fowler, published the canonical definition in early 2026. Quote, harness engineering is everything in an AI agent except the model itself. Think of it like a Formula One race. The driver is your model. Brilliant, highly trained, worth millions. But put that same driver in a busted go-kart and they finish last. Put them in a tuned chassis with great tires, real telemetry, and a pit crew, they win. The car is the harness. So what's in the harness? Fowler breaks it into 2 halves. Guides, feed-forward instructions that tell the model what to do. Agents.md files. System prompts. Skills, documentation pointers, and sensors, feedback loops that catch mistakes after the model acts. Linters, type checkers, tests, code review agents. Both halves run in 2 modes. Computational, deterministic things like a linter that always returns the same answer. And inferential, AI judges that grade other AI work. That's the framework, guides plus sensors, computational plus inferential, 4 quadrants. Every great agent uses all 4. Now, most tutorials stop at the definition. We're going to build one. There's a free open source curriculum on GitHub called learn-claude-code, built by Share AI Lab. The motto says it all, quote, bash is all you need. 12 sessions, 4 phases, 0 frameworks. Phase 1, the loop, sessions 1 and 2. You write the agent loop, a while loop that sends a message to an LLM, checks if it wants to call a tool, runs the tool, loops back. Then you add bash. Suddenly, your loop can read files, run scripts, edit code. That's the entire core of Claude Code, in about 50 lines of Python. Phase 2, planning and knowledge. Sessions 3 through 6. To-do right, your agent plans before acting. Subagents, fresh context per subtask, so a long job doesn't pollute your main thread. Skills, load knowledge on demand instead of stuffing everything into the prompt. Context compact, 3-layer compression that keeps the important bits and tosses the noise. Phase 3, persistence. Sessions 7 and 8. File-based task graphs so your agent survives a crash. Background tasks so slow operations don't block thinking. Phase 4, teams. Sessions 9 through 12. Agent teams, communication protocols, autonomous task claiming, and worktree isolation so multiple agents can work in parallel without overwriting each other. 12 mechanisms. Each one solves a real failure mode you've already hit. Want proof these mechanisms matter? On April 4th, 2026, Anthropic published a paper most developers missed. It's called, quote, Harness Design for Long-Running Application Development. Here's the experiment. Same product spec, same model, 2 harnesses. Test 1. Single agent, no planning, no evaluator, just a long context window and a prompt. After 20 minutes, the agent gave up. Cost, $9. Result, a barely functional prototype. They call it the $9 disaster. Test 2. 3 agents. A planner that breaks the spec into chunks. A generator that writes the code 1 chunk at a time. And this is the twist, an evaluator that opens the live app in a browser using Playwright, clicks around and grades the work. 6 hours, $200. Result, a polished, production-ready application. Same model, 22 times the cost, but infinitely more usable. The model didn't change, the harness did. Here's what the course series will deliver. Episode 1, already live, is the agent loop. Sessions 1 and 2, 50 lines of Python. By the end, you have a working agent that reads files, runs commands, and fixes its own bugs. Episode 2, Planning, Skills, and Context Compaction. The 4 mechanisms that explain why agents forget. You'll add a to-do-right system that plans ahead, sub-agents that isolate concerns, skills that load on demand, and a compaction algorithm so you can keep working past the context limit. Episode 3, Persistent Agents. Tasks as dependency graphs on disk. Background ops for slow work. After this episode, killing your terminal doesn't kill your progress. Episode 4, Multi-Agent Orchestration. Agent teams, communication protocols, autonomous task claiming, worktree isolation. The capstone combines all 12 mechanisms into one complete agent, built from scratch, in Python, with nothing but Bash and an API key. By the end of this series, you won't need Claude Code. You'll understand exactly how it works, and you'll have built your own. Now, let me be honest about the limits, because the hype around harness engineering is already getting silly. First, harness engineering is overkill for small jobs. If you're writing a one-off script, you don't need a planner generator evaluator. Open cursor, type a prompt, move on. Second, the behavior harness is still hard. Fowler explicitly calls it out as the least developed category. Linters catch syntax. Tests catch known failures. Nobody has fully solved, is this code semantically correct, without human review. Third, token costs scale fast. Anthropic's 3-agent harness costs roughly $200 per autonomous session. That's real money. Don't burn it on tasks. A single Claude Code session would finish in 20 minutes. Fourth, there's a blind spot the OpenAI playbook ignores. Their team had unlimited compute, top-tier engineers, and a single product. Most teams have constraints they don't. Adopting their playbook wholesale will break a normal team. In my testing, the harness engineering payoff kicks in around the moment a task involves more than 3 files, more than 1 subsystem, and more than 30 minutes of single-session work. Below that threshold, just code. Above it, engineer a harness. That's the real rule. Here's your move. Today, go fork the learn-claude-code repo on GitHub. The link is in the description. Skim the README. It's the fastest hour you'll spend this month. Tomorrow, start session 1. Build the agent loop yourself. Don't watch a tutorial passively. Type the code, 12 sessions, 1 per week. 3 months from now, you'll be the person on your team who understands how AI coding actually works. While everyone else is still arguing about which model is best, you'll be engineering the thing that makes any model great. If you want me to walk you through every session with real code, real failures, and real production patterns, hit subscribe. Episode 2 drops next week. The Agent Loop, 50 lines of Python. The Foundation. I'm Tech Whistle. Stop vibe coding. Start engineering.